Welcome back to Java Internals Crashcasts. I'm Sheila, and with me as always is Victor. Today we're continuing our journey through the fundamentals of concurrency. We're in the chapter on executors and thread pools, and we'll be diving into the ExecutorService interface. Before we start, listeners, you should be familiar with basic Java concurrency concepts and the idea of thread pools. Victor, are you ready to explore ExecutorService?
Absolutely, Sheila. I'm excited to unpack this powerful interface for our listeners. It's a crucial part of Java's concurrency toolkit.
Great. Let's kick things off with a quiz question for our listeners. Here it is. What key problem does the ExecutorService solve in concurrent programming that manual thread management doesn't address effectively?
Ooh, that's an intriguing question, Sheila. It really gets to the heart of why ExecutorService was created. Listeners, think about the challenges you face when managing threads directly. What aspects of thread lifecycle and task execution do you find tedious or error-prone? Don't worry if you're not sure. We'll break it down throughout the episode and reveal the answer at the end.
Excellent, Victor. Now, let's start with the basics. Can you give us a brief overview of what ExecutorService is and why it was created?
Certainly. ExecutorService is an interface in Java that provides a higher-level replacement for working with threads directly. It was created to simplify concurrent programming by separating task submission from task execution. Think of it as a team manager in a company. Instead of you having to hire, train, and manage individual workers, threads, the ExecutorService does all that for you. You just need to submit tasks, and it takes care of executing them efficiently.
That's a helpful analogy, Victor. So, if ExecutorService is like a team manager, what are some of the key responsibilities or methods it provides?
Great question. The ExecutorService interface provides several important methods. The most commonly used ones are 1. Submit. This method is used to submit tasks for execution. It can accept both runnable and callable tasks. 2. Execute. Similar to submit, but only accepts runnable tasks and doesn't return a result. 3. Shutdown. Initiates an orderly shutdown of the ExecutorService. 4. Shutdown. Now. Attempts to stop all actively executing tasks and returns a list of tasks that were awaiting execution. There are also methods for managing collections of tasks, like invokeAll and invokeAny.
That's quite a toolkit. I'm curious about the difference between submit and execute. Why would we choose one over the other?
Excellent observation, Sheila. The main difference lies in their return values and the types of tasks they accept. Execute is inherited from the executor interface and is simpler. It just runs the task without returning anything. Submit, on the other hand, returns a future object, which can be used to retrieve the result of the computation or check if it's complete. Also, submit can accept callable tasks, which can return results and throw checked exceptions, unlike runnable tasks.
I see. So submit gives us more flexibility and control over the task execution. Now, you mentioned shutdown methods. Can you elaborate on the lifecycle of an ExecutorService?
Absolutely. The lifecycle of an ExecutorService is crucial to understand. When you create an ExecutorService, it starts in a running state, ready to accept and execute tasks. However, when you're done using it, you need to shut it down explicitly. This is where shutdown and shutdown now come in. Shutdown initiates a graceful shutdown. It stops accepting new tasks, but allows previously submitted tasks to complete. Shutdown now, as the name suggests, is more aggressive. It tries to stop all executing tasks and returns a list of tasks that were never started. It's important to note that if you don't shut down your ExecutorService, your application might not terminate, as the ExecutorService keeps its threads alive.
That's really important information, Victor. I can see how forgetting to shut down an ExecutorService could lead to resource leaks. Are there any best practices around managing the ExecutorService lifecycle?
Absolutely, Sheila. One common best practice is to use a try with resources block, which automatically calls shutdown when you're done with the ExecutorService. Another approach is to use a wait termination after calling shutdown to wait for tasks to complete. It's also a good idea to log any tasks that couldn't complete if you use shutdown now. A good practice is to create the executor service, use it within a try block, and then in the finally block, call shutdown, and give tasks some time to complete before forcing a shutdown. This ensures that the executor is always properly shut down, preventing resource leaks.
That's really helpful, Victor. Now, you mentioned earlier that executor service is an interface. Are there different implementations of it that we should be aware of?
Great question. Yes, there are several implementations of executor service, each designed for different use cases. The most common ones are 1. Thread pool executor. This is the core implementation, which maintains a pool of worker threads. 2. Scheduled thread pool executor. This extends thread pool executor and adds support for scheduling tasks to run after a delay or periodically. 3. Fork join pool, introduced in Java. 7. This is designed for work-stealing algorithms and is particularly useful for recursive tasks. Java provides convenient factory methods in the executors class to create these different types of executor service instances. For example, executors.newFixedThreadPool creates a thread pool executor with a fixed number of threads.
That's fascinating. It seems like there's a lot of flexibility in how we can use executor service. Are there any common pitfalls or misconceptions that developers should be aware of when working with executor service?
Absolutely, Sheila. One common pitfall is submitting too many tasks to an executor service with a bounded queue, which can lead to what's called a rejected execution exception. Another is creating too many threads, which can actually degrade performance instead of improving it. A misconception is that executor service automatically handles all concurrency issues. While it manages thread creation and lifecycle, developers still need to handle synchronization and thread safety in their task implementations. Lastly, as we discussed earlier, forgetting to shut down the executor service is a common mistake that can lead to resource leaks.
Those are great points, Victor. Now, I think it's time to reveal the answer to our quiz question. Can you remind our listeners of the question and then give us the answer?
Certainly. The question was, what key problem does the executor service solve in concurrent programming that manual thread management doesn't address effectively? The answer is that executor service solves the problem of efficient resource management and task scheduling. Unlike manual thread management, executor service provides a reusable pool of threads, which eliminates the overhead of creating a new thread for each task. It also offers built-in task queuing and scheduling mechanisms, load balancing across available threads, and a clean separation between task submission and execution. This makes concurrent programming significantly easier, more efficient, and less error-prone compared to managing threads manually.
Thank you, Victor. That wraps up our discussion on the executor service interface. In our next episode, we'll be diving into Thread Pool Executor, which, as Victor mentioned, is the core implementation of executor service. Listeners, if you've enjoyed this episode, please subscribe to Java Internals Crashcasts and leave us a rating. Your support helps us continue creating these in-depth explorations of Java's internals. Until next time, keep coding.